Okay, so we're going to have a look at another question from the 2022 HSC Advanced Maths paper. So this is question 15. We're told in a bag there are 3 6-sided dice. 2 of the dice have faces marked 1, 2, 3, 4, 5, 6. The other is a special die with faces marked 1, 2, 3, 5, 5, 5. 1 is randomly selected and tossed. What is the probability that the die will show a 5? Okay, so for this question we can use a tree diagram. When you randomly draw a die out of the bag, the probability of either die is 1/3. So 1/3, 1/3, 1/3. The top die, so the first die will be a normal die. It has one branch. That will end up as 5 with a probability of 1/6. The second die, which is a normal die, also has one branch, which gets to 5. Has a bunch of other branches, of course, that get to all the other numbers. We don't care about them in this case. So that's these ones. And then the third die has 3 branches that go to 5. So it has 3 that don't and then 3 that go to 5. And the probability is 1/6 in the case of all of these. So we have 5 possible outcomes. So the probability that the dice rolls 5, let's call this P5, is 1/3 times the 6th, which is this top one, plus 1/3 times the 6th, which is this middle one, plus 3 times 1/3 times a 6th, which is these bottom 3. So we get 1/18 plus 1/18 plus 3/18. This is 18ths. This is 5/18. This fraction does not simplify. The probability of rolling a 5 in the case of this question is 5/18. And this is the answer we're after. For part B, so this is part A, this is just the first part. Now we're doing part B. Given that the die shows a 5, what is the probability that it is the special die? Well, up here we identified there were 5 ways for it to show 5. 2 of them were from the ordinary dice. 3 were from the special dice. And so that means the probability that it is a 5, the probability that it is the special die, given that it rolls a 5, has to be the number of times you could get the special dice outcomes divided by the total, which in this case is going to be 3 on 5. And this is in fact the answer to this question. Because we did this as a tree diagram, this was very easy. So getting this mark was very straightforward. If you didn't do a tree diagram and you had to think about it, you could use your union intersection formulas. You could think about special die, intersections, and so on. But because we did a tree diagram here, essentially this taught us how to think about the problem from the beginning. So this is the answer. In terms of the marking, for part A, to get 1 mark, you need 5 on 18 and some working associated with that. And then for part B, you need 3 on 5. And if you've not done a diagram that clearly shows how you're getting this, you'll need some working associated with this. The tree diagram makes it very obvious because all of these end probabilities are the same. And so there's 5, they all have the same end probabilities. So this is pretty obvious in this case. If you did it another way, you would need additional working.